Good morning, everyone. I want to sincerely thank all of you for being here, and I also want to thank Cobus for giving me an opportunity to come and talk to this esteemed audience. In many ways, I consider myself a child of MobiCom. This was the place I first published my paper, and I'm still here. I've been an active part of the community for many years, and I probably know pretty much every one of you. If you've been here for more than part of this community for more than a year, I probably know your name. And I'm happy to be part of this. What I want to do here essentially is to share some of my thoughts, having been part of SIGMobile and MobiCom, and also kind of having a perspective from the other side, the funding side at NSF, kind of seeing what are the big challenges that the mobile systems research is facing right now, and how do we take it forward? What are the challenges we need to overcome to take it forward? Again, these thoughts are all mine as a researcher. And while it may be tinged by my experience at NSF, please do not take it as any official opinion expressed by NSF. So since I have my official perch at the NSF, let me just go really quick and give you a brief pitch about the wireless networking at the programs at the NSF. We have at least 4 distinct research programs at the NSF addressing different topical areas for communications research. So we have systems, which is the program that I mainly deal with. There's the theory piece, there's a circuits piece, and there's also the spectrum focus piece. So between these 4, we kind of have a substantial amount of investment. For example, last year we invested more than $75 million in research funding for this. This doesn't include any of the infrastructure investments. This is just pure research alone. And much of the investments that we make in NSF are fundamental to the work that happens here at MobiCom. So close to 50% of the work here, the authors from the US-based papers are directly funded by NSF. And if you even look at the industry researchers who publish, I mean, they probably had to start from an NSF award when they're a grad student. So we take a lot of pride in enabling communities like this to thrive and prosper and make a substantial impact to the community. Now, of course, the work here has also led to multiple startups and tech transfers to industry. As many of this community knows, this is something that we can all take a lot of pride in, and NSF is very happy to support this. And we are living in a good era. I mean, I've been telling people around here this, wireless is enjoying a great resurgence. In the last 5 years, we have seen a doubling of proposals coming into NSF on wireless topics, and correspondingly funding has increased as well to these areas, and that's a good thing, right? So I want to give all of you a great shout out, and I think we all deserve an applause for being so creative and being engaged and striving hard to make a difference in the community through wireless research. So let's give yourself all a big hand, please. So having said that, right, let me put my researcher hat on, right? So I want to take the perspective of a non-researcher, right? As a general public, how do I see wireless? How many of you remember this "Can you hear me now" ads? Quite very few, right? Some of you, right? We no longer hear these ads in the thing. Why? Because wireless networks have become fairly commonplace. They have become reasonably reliable. You have pretty good coverage indoors and outdoors. And people have literally now taken to the smartphones as a primary means of communication, right? So they really don't understand what is wireless. Like, they don't know what this network means. They don't think about bad coverage. They just say, yeah, if it doesn't work, yeah, give it a minute, give it like a few seconds, it'll work. They don't even see this because you're using data-based applications where the connection drops and fades are kind of hidden by the nature of the transport protocols and so on. We don't use voice anymore. So you kind of assume that it just works, okay? And there's a lot of interest in apps that are built on top of wireless, right? So, but the one thing that is there from the public view is the demand for lower cost. You want to get your wireless networks for cheaper. You want to get more bandwidth for cheaper, right? So that's essentially the driving function right now. If you look at what the public wants, that's pretty much what they want. But this essentially is a problem for us because if people in the wired network will know, or the computing industry know, commoditization is a bad thing because you kind of drop out of the public imagination to some extent. So the big challenge for systems research essentially is how do we recapture the public imagination, right? And I think that's where we really have to make a big departure from whatever the current way of doing things and start exploring new frontiers, okay? We need to take bold risks and try to innovate in a way that people think, oh, I didn't know wireless could do that. And some of the stuff we do, for example, the sensing stuff, energy harvesting stuff, I mean, some of those things are actually pretty cool. And if you see the demos and the kind of press releases we get, they kind of grab the attention of people and say, oh, we didn't know we could do that kind of stuff with this. So that's nice. So we are on a good track to doing that, but we need to keep doing that, and that's a great thing. But what are the other ways in which we can recapture public imagination? So I like, this is my favorite word. I like to think about convergence. And what does convergence mean? So we are already experiencing the convergence in computing and communication. This is what our smartphones epitomize. The whole growing trend towards mobile edge computing, which carriers, everybody's trying to go towards, is already showing that. That's a trend that it's unmistakable. There is hardware and software convergence, right? The SDN's virtualization is taking the entire industry by storm, and there are a lot of interesting research problems that kind of are opening up and kind of giving us new opportunities to kind of revisit the fundamental assumptions behind how networks should be designed, right? Behind the protocols underlying this network. So it's giving us a lot of opportunity to kind of redesign stuff. There's also this notion of last mile and RAN convergence, right? There used to be this Wi-Fi world, and there used to be the cellular network world, and even cellular network, there had to be 3G and the 4G. The interoperators, they won't roam. Now everything is coming together because the devices don't care, right? You want, okay. Let me see what's going on. Let me pull it back. Okay, got it. So we have the multimodal wireless networks that the devices are ready to operate, so therefore there are interesting problems in that area. There's also convergence across spectral boundaries. So what do I mean by this? So we talk about software-defined radios, being able to operate in any band, but what it fundamentally also tells you is we no longer are restricted to operating in a particular band. And there's also a lot of interest from policy regulators who also think the same way. They think wireless has to be repurposed to doing what it does best. Each spectrum slice shouldn't be necessarily allocated for a purpose. It should be going towards whatever is needed at that time. So that gives us a lot of opportunities for us to explore the convergence across spectral boundaries. Because my favorite example is all of the interesting wireless networks that we have seen and exploring so far, whether it's cellular or Wi-Fi, they all operate on this very narrow, I would say 1.4 gigahertz worth of spectrum. Well, the entire 6 gigahertz spectrum is at play. Potentially, if you think about it, if you can repurpose any of these bands, you can take that entire spectrum band and you can play a lot with that. And if you can deliver a gigabit per second with your current small allocations, imagine what you can do if the entire band was at play, right? Just forget about the 60 gigahertz and all the other frontiers that could be opened up. So there is a lot of interesting, innovative problems, and I think the new problems for systems research comes at these interdisciplinary boundaries, right? So I think that's the thing. So these multidimensional problems will also lead to, I mean, they may be more complex to solve, but in my view, they also lead to high-impact solutions, right? Now, given these multidimensional problems, let's explore what is the role of systems. What is the systems people have to do? I think systems are there essentially to inform, to demonstrate the path from theory to practice. I think that's like kind of a basic definition. Let's look at some of the examples we have seen in the past. Full duplex, right? In theory, we know, oh, you have a signal, you cancel it to the receiver, you should be able to do other thing. But we know that's not that easy, right? The real challenge lay in how do you get the circuits and other stuff to work in a way that that doesn't drown your receivers and so on. So that the real challenge lay in showing that and building a prototype and scaling it up. The same thing with massive MIMO, right? The theory was there for many, many years. And even to this day, if you talk to a massive theorist, they'll say, oh, you can go up to infinite elements. But we know that it comes at a cost. There's a computational cost, there's a communication cost, and there's estimation cost. And all of those things are what I call a systems problems, right? And it's dynamic spectrum sharing, right? In theory, same. It's easy. Yeah, you can share spectrum, fine. Just tell the other guy, and they'll move out, and you can reuse the spectrum. It's not easy, that we all know right now. It's not that easy. Or there's been a lot of work that's happening in this space that focuses on the practical problems that are associated with it. I think that's the key role, right? Theory to proof of concept is what most of the systems work has been focused on. I think that's a big step by itself, right? But I think the bigger challenge is going from a lab bench environment to a much more outdoor, indoor, at-scale deployment. I think that is actually a much bigger problem. And I think as a community, we kind of delegate that role off to a commercialization approach, right? We say, oh, if somebody likes this thing, they will take it and commercialize it. I'll tech transfer it, I'll do a startup, whatnot, and we'll solve it. But one of the experiences that many of our community have seen is, even in a startup, you go to a startup, and then you have to do substantial research on top to take it from the prototype to a full-scale system. And that's what industrial labs do a lot of time. And they invest substantial amounts of money and effort and so on. And they solve very interesting problems along the way. And I believe that as a systems community, yes, we should do the proof of concept stuff too, but we should also keep an eye on how do we scale them up, because there's potential for much bigger impacts, and also a greater potential for translation to practice. Okay. Now, so let's assume systems research goes about doing this. Now, what are the challenges in doing so? Now, many of these challenges are familiar to everyone in the audience. I don't have to repeat this, but I'll just go through this really quick. It takes time, right? It takes multiple people to build something. There's a learning curve for new graduate students who come in. You can't get your papers out enough. There's lack of adequate tools for plug and play, right? You need, there's also a lack of credit for just building a system. You're building a system in the hope that there'll be some cutting edge results that will come out, but just if the thing doesn't pan out, that effort is kind of what you call in your mind wasted. There's lack of accrediting mechanism for doing so. Or even if you build some nice code that you want to release it to the community, you don't get credit for that, right? You don't get publication credit, right? So it's one of those repositories that's there. Nobody gives you credit for it. So those are challenges that kind of make people shy away from touching this problem and tackling it at scale. And of course, it's like I said, scaling from a lab to going a little bit bigger at scale is also a bigger problem, because like I said, there are more practical constraints we have to address. And the other challenge we face is industry developments and trends can sidestep some other stuff. So we take like 3 years to build something else happens in the industry, and boom, the whole thing is like, oh, nobody cares about this anymore. Not that it's worthless, but people don't care much about it. So that's a constant worry. That's like associated with the time issue, right? And also, the bigger challenge, I think, that was brought up today in the discussion in the morning in the board meeting, SigmaML meeting, was many of these results are hard to replicate or reproduce or verify. And that's a substantial problem. And we also have a major challenge with methodology, right? So we kind of rush things a little bit, and we probably don't pay that much attention to how we get the results and so on. So let's take some of these issues and dig a little deeper. So one thing I want to point out is, for those who believe that we don't get enough credit for publishing open source and therefore we don't want to do this, I want to bring your attention to this relatively new journal called the Journal of Open Source Software. This has been started by many passionate advocates of open source communities that are from the CS world, who believe that there should be academic credit for releasing software packages. So this is something that I think all of us should do. And it also serves as a great repository for going and finding things that may be of interest for us. So keep this in mind. Now let's look at fidelity and methodology, okay? So there are some of the issues, and I'm going to ask you a question at the end of this. I would like to hear your answer. Most of the studies have very limited number of participants. How many of you have seen papers that have 20 people who have done an experiment, and that's the paper results? How many of you have seen like really small number of participants, like less than 20? So quite a few hands up there. Okay, good. So that's a challenge, okay? There's also measurement and subject bias, right? So this is what I call as, you know exactly what you want, and therefore you're going to look only for that kind of results. Anything that doesn't agree with that, you think there must be something wrong with the way you configure the experiment, so you kind of tweak the number again to see until you get the result you want. How many of you think that we have this problem when we do our research? There you go. Okay, good. We don't have a decent mechanism, and we don't enforce null hypothesis testing, right? Often this is like a standard, this is a gold standard in medical trials and whatnot. What if you just didn't give the drug? What will happen, right? So will the person still, what is the improvement that you get out of this? How much of it can really be attributed to this? We have this problem in many of the systems work, right? We kind of attribute some of the outcomes to the specific changes we made, as opposed to environmental factors, right? And channel, it could be a channel in question that will cost the whole thing. We never have enough rigorous numbers or repetitions of experiments to kind of tease this out, whether it was because of our system or it was just the environment that did it, okay? And of course, we don't have blinded experiments. And I'm not saying double-blind experiments, that's like much higher standard. Even single-blind experiments. We do sensing stuff. we tell the students and say, oh, you need to walk around in the straight line in order so they can measure you. The student knows what the experiment is supposed to do. So they're not going to walk the way they normally walk. They're going to walk in this nice straight line really slowly, right? We have seen this in this conference, haven't we? Show of hands. How many of you have seen this, that kind of behavior in this conference, right? So we see this all the time. And yes, that's great for a proof of concept. But it doesn't get you fidelity. It doesn't get you robustness, right? So that's a challenge. And of course, we always have this big issue that we don't have a mechanism to publish negative results. Negative results are extremely powerful, especially in a novel area. When you know certain things don't work, we kind of never give the ability for people to publish those. And therefore, people waste their time rediscovering those things in their own labs, again, discarding them in the search for this one positive result that they can publish, right? So these are challenges that many communities that deal with what I call systems in other domains have handled, and as a result are much more reliable, right? So that is the key. And the other issue also is, so this goes back to the nature of how you do science, right? Science is a way of explaining observation. This is how science got started, right? Science is a way of explaining observations that you cannot otherwise explain using known methods. So you do observations, then you formulate a hypothesis, then you verify. Unfortunately, one of the other trends that happen is you kind of start off with a hypothesis, and then you start doing experiments to confirm that hypothesis. This is what I call as confirmation bias. You only want the results that you think aligns with your worldview, and you discard the results that don't match. And this is a big problem we have. I'm not saying everywhere, in every paper, but quite a few experimenters who kind of get sucked into this. And essentially, it's a waste of time and resources, right? Because like I said, systems research takes time. Why do you want to do bad science, right? So that's one. Now, so that's the methodology issue. Now, let's look at the verification piece. And I think, again, we had a great discussion, and I want to give a lot of credit to Jason Flynn, who's leading the Sigma Bell effort on this, on the reproducibility issue. I have to say that, we've been very lucky that we have never faced a situation, I'm sorry, what was that? A situation like this, okay? I hope we never have to do this in any of our conferences, any of our journals, right? However, how many of you think the systems community actually has an established method for dealing with this if it happens? Okay, good, no show of hands. Okay, so which means we have an issue, right? I mean, it's one thing to hope that we never get to this stage, but we still need to have a way of dealing with problems like this, of identifying such issues and kind of having a process to clear our names in some sense, right? So that's one thing that we need to really pay attention to. And in terms of verification, right? So again, the great conversation today morning, how many of you feel frustrated in your lab when you see this great paper that you want to go back and research and you want to verify? How many of you feel frustrated how hard it is to do so? A lot of hands, right? So this is a common problem. We empathize with this often, and the reasons are these, right? The experiments are often inadequately described. There's also the concern of, there's a lack of space in the paper. There's only 14 pages. I can only pack so much. I can't put all the other stuff in there. That's where journals can come in, right? And there can be other community repositories that can come in. So we need a method to share this other additional artifacts associated with an experiment that people can use to reproduce or replicate. And Crawdad, for example, has been a great example, right? It is a data repository. It's been in operation for many, many years, more than a decade. But if you look at the most recent submissions, it's kind of slowing down quite a bit, right? So the kind of, we had this nice push. We started that. We were in a good shape. And now we have taken our eyes off the ball, and we are no longer worried about that piece, okay? So that is a problem, right? And that's also part of the rush to publish or perish model that we have right now. And we really shouldn't get stuck with that, because we should focus on the good science, and it kind of helps each other. We can actually publish faster if everybody were able to share the experiments better, because now you're not wasting your time chasing blind alleys, okay? So unless there's a collective action, this problem is going to grow. And why is going to grow? Because we now are dealing with larger data sets and more complex systems, right? So we had much easier time dealing with ad hoc routing protocols and simple Mac firmware. Now we no longer have that. We don't have luxury of just those small things. Crawdad itself as a database repository, dataset repository, is not going to be able to handle a very large data set that are going to come from the next generation of systems. So we really need to think and brainstorm as a community how to do this, okay? So this is where I believe common platforms can help. So common platforms are tools and code bases and hardware design specs that people in the community agree on. Just like NS3 was agreed upon, NS2 and NS3 were agreed upon as a common platform for verifying routing and certain network simulations, we need similar tools, right? So, and these should become part of the publication record, in my view, right? That allows people to go back and say, how did this person do it? What are the specifications that they used, and so on. So let me just go back to the common platforms, right? So there are a lot of common platforms that have kind of stimulated work in this community. Now, Mad Wi-Fi led a huge array of research that people can be able to tweak the drivers and make, like, look at MAC level changes. The GNU Radio and Warp, among many others, that kind of set the standard, made it easier for people to, like, try something and implement and then replicate and so on. It eases evaluation. It also, many of these platforms build upon open source tools, which makes it easier for people to contribute and augment and so on. And there are a lot of community efforts going on right now to kind of create a catalog of these tools. Now, again, this is all helping the community. So I have a URL up there, and you can easily pull these pieces together and build your own testbed, which is the great thing. You can build your own internal testbed in your lab really fast. But once you can build them for a small level, but it's harder to scale them up for complex systems, right? So you can build a small RF, you can put these pieces together. You can build a SDR platform, and then you can build maybe, you cannot really create a RAN yet, right? In your lab, it takes much more effort. Now, if you want to couple it with the end-to-end network slicing and do some kind of a high-level experimentation, that becomes much harder, right? So this is where kind of a larger community testbed really helps. And many people use these. And how many of you have used any of these testbeds up here? There's RBED, there's CoreNet, a whole bunch of things in the US, in the EU, and there's many in Asia that I didn't list. And my apologies for that. So quite a few people who are familiar with and use this. And these are, the one interesting thing about this is many of these testbeds are heavily subscribed. They don't even have the bandwidth. We have a very hard time reserving time on these testbeds sometimes. And that essentially is an indicator that the community really loves this. They want these kind of tools because it helps them solve many of these open problems that systems research faces. The learning curve is really small and so on. People can jump on, get their hands on a complex system they otherwise would not be able to do. And it's a great learning tool as well, right? So we have that. And it's not just academics who use this. A lot of industry folks use this, right? So there's a huge demand for these testbeds, which kind of takes me to my next thing. So I'll kind of switch my hats a little bit from the academic side, from the researcher side to the NSF side. And by my observation as a researcher, and when I went to NSF, I started having conversations with many folks like in academia and industry, kind of trying to tackle and look at what are the common problems that we really need to solve in order to enable large-scale system research that can take us to the next decade. And one of the things that emerged was the lack of these testbeds, adequate testbeds. Even these testbeds that are listed here, they're all very focused. Many of them are very focused. They're not really looking at the entire system at the end-to-end level. And therefore, we started out this program called Platforms for Advanced Wireless Research. Okay? Now, this is a multi-year program. It's a public-private partnership where NSF is contributing $50 million and matched with in-kind and cash contributions from an array of industry partners who are also pitching an equal amount. So together, we are planning to really create this large platforms. This is a list of companies. There's 30+ companies in here, and more industry partners are welcome to join, and we are always recruiting them. So this is like a who's who of wireless research in some sense, right? Every telecom provider is there. We have chip makers, we have equipment makers, and so on. So we have these people, and what we are trying to do, we are trying to create 4 city-scale platforms. Again, when I say platforms, you'll do everything from your network and the application on top all the way down to the RF, right? And over a 5-year period, we are going to support them with $20 to $25 million. And hopefully, they are going to create a new, what I call as a wave of wireless research. And why are we doing this now? Again, going back to the discussions, right, that I just spoke earlier, there is a big change in approach with the FCC opening up a lot of spectrum licenses, spectrum bands, and allowing for flexible experimentation using the program experimental licenses. Industry is also moving at the same time away from the regimented integrated networks to more of this modular, open source based tools. So they want to get rid of the legacy infrastructure. They're looking for equipment upgrade, and decided let's just go for the ones that are much more commonly accepted and easily upgradable. And there's a need for compelling applications. So the technology is kind of the build it and they will come approach is no longer seen as viable. What happened with 3G kind of reinforced that. So now we are moving towards application-driven research needs, and there's convergence that's happening across the different boundaries that I spoke about earlier. So all of that is doing, and then there's a demand for innovations in many of these domains. There's dynamic spectrum sharing, there is programmable wireless substrates, there's backhaul, there is software configurable infrastructure, and then you have modular hardware and the ability to support multiple experimenters on the same platform. All of these are kind of giving us the confidence that we can create this large-scale system that can enable rich experimentation across the different dimensions. So this is a typical experimental life cycle, right? So you try to plan it in a way, you're going to do design and plan, execute, and so on. But how it actually happens, you spend a lot of time learning it, then things don't work. Then you have a narrow window of opportunity, and then, oh my God, there's a publication deadline. We have to get the results out, get the results, spit it out, and put it in a paper, and then you're done, right? So we are hoping to kind of break that cycle, right? So one of the things, so our goal is to have a common set of guiding principles that, first of all, enhance reproducibility. You should be able to specify an experiment, and somebody else should be able to take that spec and run it on these platforms and get comparable results, right? So that's one. And we want interoperability. We want it to be able to take results that are coming from one platform or from one domain and then take it on another platform running the same technology and get those results to somewhat agree, right, relatively speaking. And then we want to have open access, right? Everybody should have access to these platforms, and and we should have fair access to anybody who wants to pursue research in this domain. We want to focus on usability. The two platforms will provide, again, learning from our experiences with current test beds. We believe that we can easily enable a low learning curve. There we come in as a grad student, a new grad student. You come in, you spend a week learning the basics of how to use this thing with enough guided tutorials, and you start progressing from a basic user to advanced user very, very fast, without having to learn like all the documentation of every component involved and so on. And programmability. So we want to have the ability for these things to be programmable at multiple levels, starting from the PHY all the way up to the back end. Okay? And clearly we want a diverse range of topics to be supported. So these are our guiding principles. And we believe that we can do it just based on how the community has responded to the ongoing set of test beds that we have right now. So we are expected to go live. The first platforms will be awarded early next year in 2018. And they are hopefully to become operational within a 2 or 3 year period, and they will last beyond that. It will become fully available for experimenters to use, hopefully by 2020 and beyond. So, and we have 4 different platforms which are going to be staggered at different times. So for the next 7 to 8 years, we are hoping that these platforms will continue to unleash a wave of creativity that we have not seen yet. So that's our hope. And there's a whole bunch of topic areas that we believe: millimeter waves, dynamic spectrum, architectures, mobility, and so on. So there's a whole bunch of things, and anything not covered here is going to be there. Also, this application-driven experimentation. So there's a whole focus on verticals. So we are hoping that these platforms, while enabling fundamental wireless research, will also provide an option to take some basic core components, stitch them together in a reliable wireless substrate, and enable higher layer application results on top. So this is our goal, right? And just for information, there are the people from the project office that's running the program right now are here. I want to just share a shout out to Tommaso right up here, and Manu Gosain, he's right up there. And there are many others, so please feel free to talk to them. And of course, you can reach out to us as well. Now, let's go back to who are the users. This is a platform, we are going to create this. Who are the users? It's all of us, right? It's going to be open to every academic, US and international. It's going to be open to every industry company who wants to come and get time on the test beds. It's going to be open to federal users who want to verify whatever they need to verify on the policy side, spectrum side, and so on. It's going to be useful for all of us. But here's the thing. We can succeed beyond expectations because of the scale of the program, but also at the same time, we can also fail spectacularly, right? It all depends on your buy-in, right? So if the community doesn't buy in and say, hey, you know what, we don't care, we're just moving away, then all of this will be wasted. And we will also have wasted a great opportunity for us to make a substantial impact, right? Now, so what I would want this community to do is to continue to stay engaged with this program, with this platform. Again, this is not just academics, also industry members, people who do research. You have your own labs, but what we have heard, and that's the reason why we have 30 plus companies in the consortium, is that they themselves would love to have something this big, because they don't want to invest and build this, but they do one-off things, right? They don't want to build something this big and then mothball it later, because they want to have something that's continuous, that's live, that's current with the latest technology. So if you are one of those users, right, who would love to get your hands on, stay engaged, give feedback. There are going to be user groups associated with all these platforms. Join them, participate in them, and provide feedback. Okay, so that is entirely depends on us to do this. And our hope is that we will tackle the most pressing issues that are facing mobile systems research. And as part of that, I'm going to call upon the community, the SIG Mobile community, to do a few things. One is to start developing standards for specifying experiments. We still don't have it. We don't have specification language for experiments. Okay? We do not incentivize higher standards for research. The discussion today about creating, providing access, the badges for replicability, great start, right? We need to keep that going, okay? We need to encourage and incentivize shared development of tools and resources. Again, go back, look at this, this journal that came up. There are many other efforts going on right now to increase this kind of shared development of tools. Be part of it, contribute. The more we contribute, the more we gain. And we also, again, this is again a moot point, because I think there's a discussion that's already starting. We need to determine what level of standards we want when it comes to reproducibility. Repeatability is a great start. Reproducibility is a golden standard. We need to work our way to there, but I think it's a process we are starting, and I'm happy to see that. Okay, so that kind of brings me towards the end. I want to give a shout out to the program itself one more time, just to remind you that we would love to hear from you about the future of wireless networking research. We are always open to listening to our comments. Reach out to us. So it's me, and I have Monisha Ghosh, who's up here. She's our other program officer here. Feel free to reach out to us. We are eager to solicit your feedback and kind of see what we are missing, right? We are, in some sense, we are a reflection of the community, and we would love to hear from you. And it doesn't matter if you're a US-based person or an international person, academia or industry, doesn't matter. Feel free to tell us what you think we should be focusing on. We are happy to take notes. And with that, I want to thank you, and I'm happy to take questions.